So now we will try to solve one problem using Gram Schmidt process. We are going to orthogonalize the basis vectors. So this is again, this is a 3-dimension one. We have 3 vectors, 111, 111, 0, 11 and 1 to 1. So it is R3 space, real space. Okay, 3D vectors. So we are going to orthogonalize the basis. Now this vector is u1, this is u2 and this is u3. Okay, so according to that we have learned so far in Gram Schmidt process, this will be your u1, u2, u3. They are not orthogonal to each other. We will check whether they are orthogonal to each other or not. We will check. Suppose take u1 dot u2. So 111 dot 011, that will give you 1 multiplied by 0, 0. 1 multiplied by 1 will give you 1. Last 1 multiplied by 1, that will give you 1. So 0 plus 1 plus 1, that will give you 2. So they are not orthogonal to each other. If it is 0, they are orthogonal to each other. See, they are not orthogonal to each other. u1 dot u2 is not equal to 0. So they are not orthogonal. So it's clear that they are not orthogonal. We are going to construct some vectors in terms of w1, w2, w3. Those vectors will be orthogonal to each other. So this is the idea. Okay. Now, so this is, as I said, this is u1, u2, u3. So we know about this equation, w2 equals u2 minus a21 w1. So we know already this, correct? Where a21 is given as u2 dot u1 divided by u1 dot u1. What is a21? It's termed as projection operator, projection vector or projection operator, which projects one shadow into another one. So which projects. Okay. So u2. Now w1 is nothing but u1. We know already. So instead of w1, you can substitute wherever w1 is there. You just substitute u1. So u2 dot u1 divided by u1 dot u1 u1. So this equation becomes w2 equals u2 minus a21 u1. So first we will calculate u1 dot u1 because we are going to get the answer for w2, vector for w2. Okay. So first we will go with u1 dot u1. What is? Oh, first we will go with u2 dot u1. Okay. So u2 dot u1. What is u2? u2 is 0, 1, 1. What is u1? u1 is here. Now as usual, I already have calculated. As usual, this becomes 2. Now we will go for u1 dot u1. So u1 dot u1. So u1 is here. Dot with another u1. So that will be 1 multiplied by 1, 1. 1 with 1, that will be 1. 1 multiplied by 1, that will give you 3. So your projection vector becomes u2 dot u1 divided by u1 dot u1. What is u2 dot u1? 2. What is u1 dot u1? 3. So 2 by 3. So which is nothing but your projection vector. So we have computed a21. We have computed a21. Any doubt on the slide? So now we will have to use this equation to get the values of w2. So w2 equals u2 minus the projection vector u1. We have already computed for projection vector, which is nothing but 2 by 3. Okay, u2 is given already in the problem. u1 also is given in the problem. So I can substitute in the expression for w2. So this becomes, we have w2 minus a21 u1. Any doubt? u2 minus a21 u1. Okay, now I am going to multiply this 2 by 3 inside 1, 1, 1. So this becomes 2 by 3, 2 by 3, 2 by 3. So we are going to subtract 0, 1, 1 minus 2 by 3, 2 by 3, 2 by 3. So we are going to subtract 0 minus 2 by 3, that will give you minus 2 by 3. 1 minus 2 by 3. So that will give you 1 by 3. 1 minus 2 by 3. So 3 minus 2 divided by 3. So 1 by 3. Is it okay? I repeat, 1 minus is here. Okay. So 1 minus 2 by 3. 1 minus 2 by 3. Just take LCM. 3 minus 2 divided by 3. So 1 by 3. So 1 by 3. The last one also have the same 1 by 3. So W2, which is equal to this one. W2 equals this one. And we know already U1 is 1, 1, 1. We know already. Now we have obtained the vector for W2. Now we are going to check. W2 we have obtained W2, correct? This is W1. We are going to check W2 is perpendicular to W1 or not. U1 is not perpendicular to U2. We have already checked. Now we have obtained the expression for W2, vector for W2. Now we are going to check W2 is perpendicular to W1 or not. So W1 dot W2 we are going to calculate now. W1 is given as U1, we know already. W2 already we have obtained. We have already obtained W2 here. So dot product with these two will give you 1 multiplied by minus 2 by 3 will give you minus 2 by 3. So 1 by 3 will give you plus 1 by 3. 1 multiplied 1 by 3 that will give you 1 by 3. You add all the things that will become 0. Is it okay? 1 by 3 plus 1 by 3 is 2 by 3. This is minus 2 by 3. Both will get cancelled. So this will become 0. Is it okay? So W1 dot W2 equals 0. So surely it will be orthogonal to each other. It's very clear. So we have finished half of the part. Any doubt? So we started with U1, U2, U3. We started with U1, U2. They are not perpendicular to each other. Now it is very clear that using Gram Schmidt process, it's very clear that W1 is perpendicular to W2. So they are orthogonal to each other. Now we'll go for W3. So W3 equals U3 minus A32 W2 minus A31 U1. We know already this. So we know this one. The expression for A32 is the projection vector is given by this U3 dot W2 W2 dot W2. And what is A31? A31 is given by this expression. Okay, U3 dot U1 divided by U1 dot U1. Now we know that the vector for U3, we know that U1, U2, U3 as it is given in the problem. So U3 is given by 1 to 1. So we have written as 1 to 1. Okay, 1 to 1. Now we'll calculate first U3 dot W2. We'll calculate. So after calculating, we are going to calculate this. This divided by this will give you projection vector A32. So first we will go with U3 dot W2. So U3 is given by this, W2 is given by this. Any doubt? So we are going to dot product. So 1 multiplied by minus 2 by 3, so that will give you minus 2 by 3. And 2 with 1 by 3 will give you 2 by 3 plus 1 by 3. This minus 2 by 3 plus 2 by 3 will get cancelled. You have 1 by 3. The answer will be 1 by 3, which is nothing but U3 dot W2. So we have completed this. Now we will calculate W2 dot W2. So W2 dot W2. So that will give you W2 is here, your W2 is here. So minus 2 by 3 will give you 4 by 9. Then 1 by 3 multiplied by, with dot product with 1 by 3 will give you 1 by 9. 1 by 3 with 1 by 3 that will give you 1 by 9. Okay, so you'll have 4 plus 1 that will give you 6 by 9. So we have calculated for W2 dot W2. So this part is over. Now we go for U3 dot U1. U3 dot U1 is given as your U3 is here, U1 is here, U3 is here according to the problem. U3 is here, U1 is here. So 1 multiplied by 1 will give you 1, 2 dot product with 1, 2, 1 with 1 that will give you 4. So U3 dot U1 is 4. What about U1 dot U1? So 1, 1, 1, this also 1, 1, 1, the answer is 3. Okay, now we have completed for U3 dot U1 divided by U1 dot U1. So this part also is over, this part also is over. So we can insert everything into W3. So W3 will be U3. What is U3? 1 to 1. So 1 to 1 minus, what is this one? 1 by 3. So you have 1 by. Okay, divided by W2 dot W2. 6 by 9. So we'll have to reverse and write. So 9 by 6. What is W2? We have already completed W2 earlier. Correct? Minus 2 by 3, 1 by 3, 1 by 3. So this is what? Minus U3 dot U1. U3 dot U1 is 4. U1 dot U1 is 3. So 4 by 3. What is U1? Triple 1. 1, 1, 1. Any doubt? Any doubt? So now this will be 9 divided by 18. So that will give you 1 by 2. So 9 divided by 3, 6 are 18. So 9 by 18 that will give you 1 by 2. I have written as it is. The other things are all as it is I have written. Okay, any doubt? Very simple. So now we'll go for 1 to 1 the same term, and the next term I have multiplied. I have multiplied with 1 by 2. So this term becomes minus 2 by 6, 1 by 6, 1 by 6. See here, minus 2 by 6, 1 by 6, 1 by 6. The next term will be 4 by 3, 4 by 3, minus just take out. Okay, 4 by 3, 4 by 3, 4 by 3. Now you have to use minus sign. So now you can easily subtract or add. So this becomes 1. This is minus is there. Minus minus plus. So this becomes 1 plus 2 by 6. And the next one will be minus 4 by 3. So this is first vector. Second one will be 2 minus. This is minus is common. So minus 1 by 6. And here minus 4 by 3. So this is second vector. And the last one will be 1 is here. Minus 1 by 6. And this becomes minus 4 by 3. Now you just simplify this. I can write 1 as 6 by 6. I can write 1 as 6 by 6. 2 by 6, let it be like this. Here this can be written as minus 8 by 6 because I have denominator as a common one. I have changed denominator as common. So that's why I have written like this. And here too I can write 2 as 12 by 6. Minus 1 by 6. This can be written as minus 8 by 6. So 1 as usual I can write as 6 by 6 minus 1 by 6. This will become minus 8 by 6. So this term becomes 6 plus 2. So you have 6 plus 2, 8. 8 minus 8. So this becomes 0. Next term becomes 12 minus 1 minus 8. This becomes 1 by 2. 12. Here you have minus 1 minus 8. So this becomes minus 9. 12 minus 9 is 3. 3 by 6 is 1 by 2. So 1 by 2. Can you do? The last one. 6 minus 1 minus 8. 6 minus 1 minus 8. So minus 3 by 6. Minus 1 by 2. So minus 1 by 2. So we have completed for W3. Any doubt on W3? So we have obtained W3 now. So W3 dot W1 we'll check whether they are orthogonal to each other or not. So this is your W3. We have already completed. W1 is nothing but U1. So U1. So dot product with these two, that will give you 0 plus 1 by 2 minus 1 by 2. Answer is 0. Now we'll go for W3 dot W1 is 0. We'll go for W3 dot W2. So this is your W3 and this is your W2. Dot product with these two, that will give you 0. So this will become 1 by 2 multiplied 1 by 3, that will give 1 by 6. Minus 1 by 2 multiplied 1 by 3, that will give you minus 1 by 6, which is equal to 1 by 6 minus 1 by 6 equal to 0. So W3 dot W2 equal to 0. So they are orthogonal to each other. Okay, any doubt? So three vectors are given. U1, U2, U3 it will be given, and they are not orthogonal to each other. And you are going to use Gram Schmidt process in such a way that you have two expressions for W2, W3. W1 equals U1, we know already. So you will have two expressions for W2 and W3 in terms of U1 and U2. Okay, now you will have to find out A32, A31 and get the expression and get the coordinates or the vectors for W2 and W3. Now you check W2 is perpendicular to W1 or not, you can check. Similarly, W3 is perpendicular to W1 or not, that also you can check. They are perpendicular. So we started with U1, U2, U3, they are not perpendicular, they are not orthogonal, whereas the obtained values of W1, W2, W3 through Gram Schmidt process, they are orthogonal to each other. It's very clear. So as I said, in physics, especially in physics, in quantum mechanics it is used because two vectors should be orthogonal when you are going to consider for ground state and the excited state. All the excited states, they will be always perpendicular to the ground state. So it will be a complex number. Okay, complex conjugate of ground state. Okay, now we will have one assignment. This assignment you are going to use Gram Schmidt process and you are going to orthogonalize the basis 1, 0, 1, 1, 0, minus 1 and 0, 3, 4. Okay, and this assignment already we discussed in the last video lecture. and this is about linearly independent or linearly dependent vectors or not. You just check. Okay, so when you are going to take the determinant, the answer is 0. What is the linearly? Not orthogonal. For linearly independent or linearly dependent vectors, which is equal to 0 means independent vectors. Okay, not equal to 0 means. So one vector can be written in terms of another vector, dependent vector. One vector cannot be written in terms of another vector is independent vector. So usually in quantum mechanics, the set of vectors always will be linearly independent vectors. For example, just take I, j, k. They are all linearly independent vectors. So in this class, we discussed the Gram Schmidt process, which is very, very important one. Those vectors which are not orthogonal to each other, with the help of Gram Schmidt process, we can make those vectors as orthogonal to each other. So thank you, students. We will see in the next class. Bye.